Welcome everybody to Mathematical Bridge channel. Today we will learn circle geometry and basically we will learn some theorems and some quadrilateral based questions we will also do, like tangential quadrilateral and cyclic quadrilateral. So let us start. First of all, everybody of us know what is circle and what is segment, what is arc, what is circumference. So we will not be covering that basic parts, but we will be covering from basic theorems. First of all, I want to mention, suppose this is a circle and this is the center of the circle named as O, and we draw a radius R. We draw a radius R. And suppose this circle is named as omega. In most of the mathematical competitions, circles are named as omega. You may have seen in INMO or IMO, the circles are named as omega. So this circle will be represented as omega OR. The common format of representing a circle is COR. Here O means the center, and R is the radius of the circle. Now suppose this is a circle with radius 4 and center named as P. Now this circle will be represented as CP4. CP4. Now 4 is the radius of the circle. From this part you can understand it is the radius of the circle, and P is the point that is the center of the circle. P is the center of the circle. I think it is clear up to this step. Please write in the chat yes or no. Please write in the chat. Please write in the chat. Is it clear up to this step? Is it clear up to this step? Okay, so everybody responded, it is clear. Okay. Now, the very basic theorem that comes upon is related with diameters and chords. The very basic theorem which we will study is related with diameters and chords. So first of all, what is a diameter? Diameter is the largest chord of a circle. Please write it. Diameter.
Double of the radius.
Yeah, right. Diameter is the largest chord of circle. That passes through center. Now see, we are doing from very basic. But this much basic questions will obviously not be asked in Pre-RMO. So, but we are still doing because many of you fear circle geometry, triangle geometry, and quadrilaterals. So we are doing from the basic parts. Now let me tell the first theorem that is related with chords. The first theorem that is related with chords. Yeah. So please note down. Equal chords of a circle. Equal chords of a circle are equidistant from the center. First of all, note it down, then I am explaining it. What does it mean? Equidistant from the center. Equal chords of a circle are equidistant from the center. First of all, note it down. Now suppose this is the center of the circle. Suppose this is the center of the circle O. This is the chord of the circle AB. Suppose this is the chord of the circle AB. Suppose this is the chord. And suppose this is another chord of the circle CD. Name it AB, CD. Now, as per the conditions given, AB is equal to CD. AB is equal to CD. Now, if AB is equal to CD, then it means the distance between AB and CD, that is, let us take PK. PK and the midpoint of PK be N. Now it tells that Pn equal to Kn. This means they are equidistant from the center. That is OT is equal to OL. OT is equal to OL. Note it down. So this is the explanation of the theorem, the first theorem related with chords. Is it clear? Please write in the chat. Please write in the chat. Is it clear or not? Everyone, please respond. Is it clear or not? Only Chakrat sends the message. I believe it is clear. Now let us see the theorems. Yeah. So the first theorem, as I already told, okay, let us also see the figure from here. Yeah. So let me explain one by one. The first theorem, as I already told, equal chords of a circle are equidistant from the center. Now, similarly, equal chords of a circle subtends equal angle at the center. Equal chords of a circle subtend equal angle at the center. Now, this is very obvious. See, let AB is equal to CD. Chord AB is equal to CD. Now, you see, suppose this is a center O. OA is equal to OC is equal to the radius of the circle. Similarly, OB is equal to OD is equal to the radius of the circle. Now, these two angles are vertically opposite angles, isn't it? These two angles are vertically opposite angles, isn't it? These two angles are vertically opposite angles, right? Now, from this thing, we can easily tell that triangle AOB is congruent to triangle COD by SAS criteria. SAS criteria. So not only this angle, but by CPCT, all these angles are equal. By CPCT, all these angles are equal. Right? So this was the second theorem. This was the second theorem. Okay. Now let us move. To the third theorem. Diameter is the largest chord passing through the center, as I already told, and diameter is twice the value of the radius. It is also a well-known fact. Now let us move to the next page. And everyone, don't worry. If you are in our Telegram channel, then all the notes will be shared. And also, if you are viewing in YouTube, then please join our Telegram channel too. Okay. Now let us see the next slide. Okay. Now from here comes the next theorem. This is a very important theorem. See what this theorem tells. The perpendicular from the center of a circle to a chord bisects the chord perpendicularly. Now see, a perpendicular from the center of the chord will always, if it bisects the chord, then it will bisect perpendicularly only. So this is not an important word in this case. So we have to prove the following. So how to prove the following? Let us see. Suppose OD is perpendicular to AB. OD is perpendicular to AB. Now from the circle, we can easily tell OA is equal to OB equal to radius. OA is equal to OB is equal to the
radii of a circle.
Yeah, radii of a circle. And now OD is equal to its length OD, and angle ODA is equal to angle ODB is equal to 90 degrees.
90 degrees.
Yeah, SAS congruency. By SAS congruency, triangle OAD is congruent to triangle ODB. Is congruent to triangle ODB. Now by CPCT, you can tell AD is equal to BD. Now by CPCT, AD is equal to BD. Now, if AD is equal to BD, then that is what the theorem actually tells. Now, from here, if there is a right angle involved, then I already told while doing triangle geometry, we have already finished triangle geometry. We are very talented. So while doing triangle geometry, we have already known that wherever there is a right angle, Pythagoras involvement is always
Pythagoras Theorem.
right. So Pythagoras theorem is also here. So the man Pythagoras will not leave us after even death. After even death, he is not leaving us. Now in circles also Pythagoras is involved. So let us see some questions based on Pythagoras theorem. So now let us move. Okay. Okay. Now this is the inscribed angle theorem. So what is the inscribed angle theorem? Let me explain this. Inscribed angle theorem. Suppose this is A, this is B, this is C, and this is the center O. Now, if this angle is theta, then this angle will be 2 theta. If this angle is theta, then this angle will be 2 theta. Now, here I want to prove one little thing that is very important for pre-RMO. So, what is that? Now, suppose we extend B to point D here, and C also to point D. Now, please write down A, B, C, D is a cyclic quadrilateral. Now, what is a cyclic quadrilateral? Any quadrilateral that is inside a circle is a cyclic quadrilateral. And the points of the vertices of the quadrilateral, the cyclic quadrilateral, are known as concyclic. Now, suppose this is angle theta, suppose phi. This is angle phi. Now, by the same theorem, this is 2 phi. Now, this is a circle. And to tell that 2 theta plus 2 phi is equal to 360 degree. This means theta plus phi is equal to 180 degree. And this is one of the most important theorems that tells you that the opposite angular sum of a cyclic quadrilateral is nothing but 180 degrees. Is it clear? Up to this step, is it clear?
Yes.
Okay. So now let us move. Let us see what is there next. Okay, so yeah. Okay, now let me remove this ink because so this is what I actually told. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. This is very important now. Remaining part of the circle. See, PQ is the segment. Now, in this remaining part, suppose this, we take this. Now this, if this is theta, then this is 2 theta. If this is theta, then this is 2 theta, right? So on the remaining part of the circle, but not on this segment, I hope it is clear. Okay. Now let us move. Okay, so an easy question. Everyone, please try this for 2 minutes. Okay, try this for 1 minute. And if you need more time and viewing via YouTube, then you can pause the video, of course. And your time starts now. Okay, I received one answer, and please write the answer only via chat. Write the answer only via chat. Okay. So one more answer I got. So Chakrat, you were right, but Arkaprabha, you were wrong. Okay, now let me show you how to do this problem, exactly how to do this problem. So let us see. Okay, sorry. Oh my God. So yeah. Suppose this is the chord AB of length 12 centimeter. Suppose this is the chord AB of length 12 centimeter. This is the center of the circle O. This is the center of the circle O. Trilok, you are wrong. And this is the radius. Suppose this is the radius. This is the radius OB of length 8 centimeter. Radius of 8 centimeter. Now we drop a perpendicular, suppose OD on AB. Now we know by a theorem that the perpendicular from the center on a chord bisects the chord. Now the chord is of length 12 centimeters. So now it is bisected and it is given by 6 and 6 centimeter. Now this is 6 centimeter, this is 8 centimeter, and the distance between the chord from the center to the chord is OD. Now by Pythagoras theorem, the man who never left us even after dying, we can tell that OD square is equal to 8 square minus 6 square. This means OD is equal to root over of, and this is 28, which is equal to 2 root 7, which is equal to 2 root 7. So the distance between the center and the chord is nothing but 2 root 7. I hope it is clear and you may copy it down. Okay, now let us move. Now let us move and see what is waiting next. Okay, tangential quadrilaterals. First of all, let us draw the figure. So this is exactly what is tangential quadrilateral. Now let us name it A. This is B. This is C. This is D. So first of all, what is a tangential quadrilateral? The quadrilateral that is formed via joining the tangents of a circle. The 4 tangents of a circle is known as the tangential quadrilateral. Now, in this case, ABCD is a tangential quadrilateral. Now, if ABCD is a tangential quadrilateral, then there are 3 properties that must hold. There are 3 properties that must hold. So, what are the properties? Let us see one by one. Okay. So, first of all, let me change the ink. Okay. Now, the first thing that I will tell is known as Pitot's theorem. You may write it, Pitot's theorem. And this is very important. Please write it down. It tells you that AB plus CD is equal to AD plus BC. AB plus CD equal to AD plus BC. That means this length plus this length is equal to this length plus this length. So this is the first property. Now this is a theorem, but this is a property for the tangential quadrilaterals that must hold if AB and ABCD is a tangential quadrilateral. If this property does not hold, if this theorem is false for this quadrilateral, then it is not a tangential quadrilateral. Please note it down that if this property does not hold for this particular quadrilateral, then it is not a tangential quadrilateral. So this is the first thing. Now this circle has a center O. It has radius R, and this radius. Okay, my pen is not working. I don't know why. Wait for a minute. This radius is known as in radius. Now this in radius is represented by small r, and the area of this quadrilateral is represented by delta. Area of this quadrilateral is represented by delta. Fine. Now the semi-perimeter of this quadrilateral is AB plus CD plus AD plus BC by 2.
By 2.
Yeah, now see one thing, observe one thing. AB plus CD plus AD plus BC by 2 is given. Now we know AB plus CD is equal, AB plus CD is equal to AD plus BC. If this is K, then this is also K.
Brahma-Gupta formula.
2K by 2, 2K by 2, which is equal to K. This means the semi-perimeter can also be written as only AB plus CD. But why are we leaving AD plus BC? They will cry, right? So in this case, while we are taking AB plus CD, then other will cry. So let's not leave them. Let us do what? We write them also, so that they will also be happy. Semi-perimeter is AB plus CD, which is equal to AD plus BC. Now I'm writing it freshly once again. Wait. Yeah. So what is actually the requirement of this area, semi-perimeter, in radius? What is the relation between them? There is a relation between them, and this relation is super important for pre-RMO, KVPY, NSEJS, in fact, AIME. And other mathematical Olympiads too. So the relation is the in radius is equal to the area divided by semi-perimeter. So this is the first relation I told. This is the second relation I told. First relation I told AB plus CD is equal to AD plus BC. AB plus CD equal to AD plus BC. And this is A, this is B, this is C, and this is D. Now there is a third relation. There's a third relation, and this third relation is every regular polygon are cyclic as well as tangential. Every regular polygon. This means a square is regular as well as, a square is a regular polygon and it's cyclic as well as tangential. And more figures like a regular hexagon. Suppose we take a regular hexagon also. This is also tangential and cyclic. So all regular polygons are tangential as well as cyclic. Now let us move forward. Okay, so this is what exactly I told you just now. This is the first thing, this is the second thing. All the things I told. So try this question. This is also an easy question, and I will be solving this as an example question. So how to do this? Now one thing from here you can do, that is, see, two sides are equal to each other, 5, 5, 12, 12. The first thing you will do is to take this as a rectangle. But if you are taking this as a rectangle, then you are doing the greatest mistake of your life. Do you know why? Because, see, suppose this is the rectangle. Suppose, okay, sorry. I don't know why it is. Yeah, suppose this is the rectangle. Let me draw it. Yeah. And this be named as ABCD. This is 5, this is 5. This is 12, this is 12. Now I already told that if there is a tangential quadrilateral and it is having an in radius, If it is having an in radius and it is a tangential quadrilateral, then it must hold the Pitot's theorem. But suppose in this case, for this rectangle, is it holding the Pitot's theorem? Let us check. Now AB plus CD, that is 24, is not equal to AD plus BC, that is 10. So this figure is not a rectangle. But the question is absolutely correct. The question is absolutely correct. And for your instance, I can tell you, and for your convenience too, I can tell you one thing, that if you take this figure to be a rectangle also, then also coincidentally, your answer will be same. Your answer will be same. But if this is a subjective exam which you are giving, then you will get 0, because for a rectangle like this, Pitot's theorem will not hold and it will have no in radius. Then how can you draw a rectangle for this type of thing? So let us draw a general quadrilateral. Let us draw a general quadrilateral. Let us draw a general quadrilateral. Okay. So suppose this is the quadrilateral. Yeah, Arkaprabha, you are right. Suppose this is the quadrilateral. And this is the second side. This be the diagonal of length 13. This is 12 and this is 5. Now 5, 12 and 13 is a Pythagorean triplet. The man who died is not leaving us in this case also, and this is a Pythagorean triplet, making this a 90 degree, that is a right angle. If this is a right angle, then by simple thing, that is you have to find the semi-perimeter here. So in this case, semi-perimeter is 17, and the area is half times 12 into 5, that is 30. 30 for this part and 30 for the second triangle. So the total area is nothing but 60. So the in radius, as told, is area by semi-perimeter is equal to 60 by 17. So this is your answer. This is your answer. So the in radius of a quadrilateral with sides 5, 5, 12, 12, and one diagonal being 13 is nothing but 60 by 17. Is it clear? Please write in the chat if it is clear or not. Okay, so it is clear. That's nice. So let us move. Now this is a very good question, but still I will be solving it as an example. If you need time and viewing through YouTube, then you can obviously pause it and try it and see the solution later. But now I want to mention one thing. This particular problem is easily a PRMO 2-marker problem. PRMO or IOQM as named nowadays. 2-marker problem. So PRMO or IOQM 2 marks. So how to do this problem? First of all, let us draw the figure. I believe the figure is drawn. Yeah, the figure is already drawn. So this is the figure. Let us name it as A. This is B. This is C. And this is D. Nice. Now AD is given as 12. CD is given as 10. Okay. AB is given as 15. Nice. You have to find the in radius of the in circle, which is n. Then find 4n. Okay, I see. How to approach this problem? Now AD is perpendicular to AB as given. So this is a 90 degree. This is a 90 degree. Now one thing by Pitot's theorem, since this is this has an in circle and this has an in radius, so by Pitot's theorem you can tell that BC is nothing but 13, because 10 plus 15 25 and 12 plus 13 is also 25. I'm writing it. since AB plus CD is equal to AD plus BC, this means AB putting in 15 plus 10 is equal to 12 plus BC. Therefore, BC is equal to 30. So this is the first thing you can do. Now the next thing is we have to do a construction. So what is the construction? Now I will tell you a method to do in this case. See, you were given with 13, you were given 12. Now if you get a 5, then you can easily apply Pythagoras theorem, since 5, 12 and 13 is a Pythagorean triplet. Now how can you arrange a 5? You can arrange a 5. How? Let us see how. This is by taking Cn perpendicular to AB. Let us take Cn perpendicular to AB. Now this is also 90 degree. Now all the angles are 90 degree, and this opposite angle sides are equal. So 10, this is 10, this is 5, total is 15, this is 12. Now this is a rectangle. So you can tell that ADCN is a rectangle. Oh wow, that's nice. You find a rectangle and you find triangle CBN. A right angle triangle. Now the area of triangle CBN is nothing but 30. Right? Similarly, the area of rectangle ADCN is 10 times 12, length into breadth, which is 120. Now the total area that is represented by delta is equal to 120 plus 30, which is 150. The semi-perimeter for this total trapezium is nothing but 25. S is equal to 25. This means the in radius n is nothing but 150 by 25, which is equal to 6. And this makes 4n to be 24. 4n to be 24. And that is the right answer. You are correct, Arkaprabha. You are correct, Chakra. So this was a good problem as far as Mathematics Olympiads are concerned. Also for, no, this is not an AIME level problem, of course. This is maybe Russian Mathematics Olympiad level. Now see. Now we have finished about tangential quadrilaterals. We have finished about the basic theorems that shall be covered in cyclic quadrilaterals. Not that we will stop now. We will also learn cyclic quadrilaterals. We will also learn about cyclic quadrilaterals. Let us see. Please make a heading cyclic quadrilateral. Cyclic quadrilateral. Now, what is a cyclic quadrilateral? As I already told, if there is a quadrilateral inside a circle, like in this case, this quadrilateral is inside a circle. Suppose this is be named as A, this is D, this is B, this is C. So ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. And the vertices A, B, C, D, the points A, B, C, D are known as concyclic points. Good. Now, angles and lines. Lines and angles are given equal importance. Lines and angles are given equal importance in geometry. It is not that we will do racism for lines and angles. Have I ever told that if lines comes, then angles are to be kicked out? No. So if we have done a favor for lines in tangential quadrilateral, then we will do favor for cyclic quadrilateral via giving them the value for angles. So angles and lines go side by side. So in this case, as I told, the sum of opposite angles is 120 degree. That is angle B plus angle D is equal to angle A plus angle C. Now it seems poetic. it seems poetic because in that case, lines are involved. In this case, angles are involved. That means cyclic quadrilateral and tangential quadrilateral are partnered for whole their life. So that is very nice. I hope it is clear. Please write in the chat yes or no. And if you are seeing the premiere in YouTube, so you can write in that chat also. Okay. Now let us see next. Let us see next. Now, as I already told that angles and sides are given equal importance. Angles and sides are given equal importance. By meaning this, we don't tell that since lines are given importance in tangential quadrilaterals, we will not give importance to lines in this cyclic quadrilateral. We will also give importance to this cyclic quadrilaterals by giving them lines. By giving them lines. So here lines and angles are working as their feeding purposes. Suppose angle is milk, line is chocolate. So chocolates and milk both are necessary. Now we have given chocolates to one of them. We are not given milk to one of them, but that does not mean that we will not give milk and chocolate to both of them. We will give milk and chocolate to both of them, but the first priority for tangential quadrilateral is milk, and the first quality the first quality for the cyclic quadrilateral is chocolate. Isn't it? Please write yes or no. Okay, now we have given them chocolate. So what about the milk? So for milk, there comes a person known as Ptolemy. There comes a person known as Ptolemy. Now this Ptolemy is also a very bad person. This Ptolemy is also a very bad person. If there is a chance, if there would be if there comes a chance ever in time space, then you should kick this Ptolemy, this Pitot, this Pythagoras, kick them all out. Kick them all out with as much might as you can, because these are the biggest culprits of geometry, and mainly this Euclid. Kick them all, because these are the culprits of geometry. They make geometry hurt. But geometry is not that hurt, because Ptolemy is giving a statement, and this statement can change your life. This statement can change your life. And how this statement can change your life? Let us see how this statement can change your life. So this statement tells you AB into CD plus AD into BC is equal to AC into BD. Now AB into CD, and these are the diagonals AC into BD. Let us draw the diagonals to AC into BD. So AB into CD plus AD into BC equal to AC into BD. Please tell it with me. AB into CD plus AD into BC equal to AC into BD. Please tell it with me. AB into CD plus AD into BC equal to AC into BD. Please repeat. AB into CD plus AD into BC equal to AC into BD. So this is Ptolemy's theorem. This is Ptolemy's theorem. Now, not only that Ptolemy is only the culprit, not only that we Indians are very good, not only this that we Indians are very good, there are culprit among Indians also. And from ancient time, culprits are ongoing. The culprits are coming and going. So one of those culprits is Brahmagupta. One of these culprits is Brahmagupta. So let us make the same quadrilateral. And this Brahmagupta, what did he do? Let us see. Let me change the ink. Suppose AB is the measurement of AB taken as mod AB. Mod AB, see, in geometry, whenever you take a mod, that does not mean to make positive and negative. That means you have to find the numerical value. You are considering the numerical value. Now this AB is taken as D. you take the measurement of AD as say A. You take the measurement of say CD as B, and you take the measurement of BC as C. These are the measurements. The semi-perimeter is told as S, which is equal to A plus B plus C plus D by 2. Now this culprit Brahmagupta tells you, the area of ABCD, is equal to root over of S minus A times S minus B times S minus C times S minus D. Repeat with me. The area of ABCD is equal to root over of S minus A times S minus B times S minus C times S minus D, which can be represented also as pi CYC S minus A, pi CYC S minus A. So this culprit Brahmagupta told this formula just to annoy us. So please repeat with me, who are the biggest culprits of geometry? Who all are the biggest culprits of geometry? So the first culprit of geometry is Euclid, and his geometry we all are studying. The second culprit is Pythagoras. Even after dying, this culprit is coming in every theorems, every parts, that is of circle geometry, triangle geometry, every types of geometry. This is one of the biggest culprits. This is one of the biggest culprits. Okay. Now the third culprit is Ptolemy. Ptolemy is giving a theorem in circle. Which theorem is he giving? He is giving that AB into CD plus AD into BC. Repeat with me. AB into CD plus AD into BC equal to AC into BD. AB into CD plus AD into BC equal to AC into BD. So another culprit came. Now second, another culprit is Pitot. What did this culprit do? This culprit gave a theorem for tangential quadrilateral. What is the theorem? AB plus CD equal to AD plus BC. AB plus CD equal to AD plus BC. And the next culprit is Brahmagupta. He is an Indian culprit. Brahmagupta. What did he told? He told that the area of the tangential quadrilateral is a cyclic product of S minus A, where S is the semi-perimeter. So these are the 5 greatest culprits of circle geometry. And this Euclid and Pythagoras, kick them out of your mind. Just kick them out of your mind, because they are not only culprits, they must be hanged. Because they are the greatest culprits. Right? And this culprit is also told as father of geometry. This culprit is also known as father of geometry. And why are they culprits? They make geometry hard. But we are police, and we actually catch culprits and make these hard things into easy. And this is how you get circles, not to be a hard topic of geometry, but this is an easy topic of geometry. Right? So at a glance, if we see, Pythagoras and Euclid, as always, are culprits, are in everywhere. But the most important theorems, the most important culprits we came across in today's session is Ptolemy, this Pitot, this Brahmagupta. So is it clear up to this step? Please write in the chat. Okay. So everybody please write in the chat. In the same order as I have told. The greatest 5 culprits of geometry. Okay, number 1 is Euclid. Who is the second? Yes, Srinivas, you are late. We are closing the session. You can see the YouTube video. Okay, who is the second culprit? Pythagoras. Who is the third culprit? Ptolemy. Why is Ptolemy a culprit? Why is he culprit? What is his worst contribution towards humankind? Ptolemy's theorem, right? And what is Ptolemy's theorem? Ptolemy's theorem is AB into CD plus AD into BC equal to AC into BD, which works for cyclic quadrilateral. I'm writing once again here. Yeah, AB into CD plus AD into BC is equal to AC into BD. Remember this as rhymes. These are all rhymes, not theorems. These are rhymes. Okay. And the next culprit is Pitot's. Why is Pitot's the culprit? Pitot is culprit because Pitot gave the Pitot's theorem for tangential quadrilateral, that is AB plus CD equal to AD plus BC. AB plus CD equal to AD plus BC. And the Indian culprit, the worst culprit, the biggest culprit of our country, whom the country nurtured only for making geometry hard, is Brahmagupta. Brahmagupta. What he told? The area of the cyclic quadrilateral is the cyclic product of the semiperimeter minus its numerical values, and S is A plus B plus C plus D by 2. A plus B plus C plus D by 2. So we made all this at a glance. Now it is very much difficult sometimes to actually find out the cyclic quadrilaterals, the tangential quadrilaterals, and all those. So for that thing, we will have a practice session. After this session, we will have a practice session. So if you are viewing through YouTube, don't miss that practice session, because in that practice session, we will be doing the problems based on the theorems given by these culprits. Based on the theorems given by these culprits, not theorems. Those are the statements that are taken into account by us from these culprits. Clear? So I think it is clear. Okay. Now, yeah. So thank you for turning in, and do subscribe to our channel, because that does not spend your money, but only some amount of energy to click that red button and to press the bell icon. So thank you, everybody. Thank you.